Let's go ahead and review the ideas we've covered so far in Unit 2 by going over this practice mid-test. So we're going to talk about solving equations. Please make sure when you're doing this on the practice test or on the actual test, please make sure you show all your work and thinking so that whoever's grading the test can tell that you know exactly what you're doing. We want to write our answers in the correct format, so that's going to be as ordered pairs on most of these. And make sure you circle your answer here. So we'll take a look at the instructions for the first one. It says, solve each system by graphing. Describe each system using appropriate words, consistent, inconsistent, dependent, and or independent, and label at least 2 points on each line. So I'm going to slide this down here. We'll go ahead and get started on this one. The nice thing about number 1 is these are both in slope-intercept form already. So we can tell that this one crosses at 4, has a slope of -1. So we're going to go down 1 and right 1, down 1 and right 1, down 1 and right 1. So we're going to keep going like this little stair-step pattern here. We're going to do this on the calculator in just a second, but I'm going to go in both directions. Draw this as straight as I can. And we'll make that look really nice. Remember, go to the edge of the graph and then put arrows on each end. And then the second one, I'm going to go ahead and do this one in blue. This one crosses the y-axis at -5. So we cross down here. And then the slope is 2 over 1. So we're going to rise 2 and run 1, rise 2 and run 1, rise 2 and run 1. You'll notice that we run into that nice point right there, so that looks good. And then we'll do a little bit in the other direction, down 2 and back 1. That's the opposite of going up 2 and right 1. So we'll draw this line right here. And we've got that point right there where they cross. So that looks to be the point, let's see, that would be 3, 1. So we're going to go ahead and circle that as the answer. We'd name this using these words. So this has an answer, so it's going to be consistent. This is going to be consistent, and because it only has one answer, these lines are independent of each other, we're going to say it's consistent and independent. Independent. Okay. So let's go ahead and circle that right there. Now again, we want to make sure that we've got 2 points on each one of these lines. So the easiest point to graph would be the y-intercept other than that point of intersection. So this is going to be the point 0, 4. And the other one's going to be the point, let's see, that was a 0, -5. So we've got a point on each line. We've got the intersection point, and we're all set to go there. Let's take a look at the next one. So on this one right here, we've got a little bit of work to do. The second one is written in slope-intercept form, but the first one is not. So let's go ahead and do that. We're going to move the 3 over to the other side, that 3x to the other side by adding 3x. So this is going to give us 2y, and this is going to be a positive 3x when it gets over there, and then -2. And then, of course, we're going to divide both sides by 2, so those are going to cancel. This is going to be 3/2 x, and then we've got -2 over 2, so that's going to be a -1. And let me make that look just a little bit better. So that line right there is what's going to be graphed. So we're going to go ahead and make this cross at -1 and have a slope of 3 over 2. So that's going to rise 3 and run 2, rise 3 and run 2. So we go like that little stair-step pattern. The opposite of going up 3 and right 2 would be down 3 and left 2, down 3 and left 2. So it's going to look something like that. So straight as we can there. And the other one, this one's all set for us. So this one crosses at -6. And the slope is -1. Got a -1 right there. So we're going to go down 1 and right 1, down 1 and right 1. The opposite would be up 1 and left 1, up 1 and left 1. So you can see that we cross at this nice point right here. So we're going to go ahead and draw that line right there. That point of intersection looks like it would be back 2 and down 4 from the origin. So that point of intersection is going to be, let's see, -2, -4. We'll go ahead and circle that. This is the point of another point on that line right there. So that's going to be -1, 0, -1 on that one. And then the other one's going to be 0, -6. Nice easy point to graph there. And then of course this one has an answer, so it's consistent and the lines are independent of each other. We only have one solution. So this is going to be consistent. And if you want to abbreviate, consistent and independent. So we'll just write INDEP right here. And we've got that. Now, you can use a calculator to do these problems, so I'm going to go ahead and shrink this down, pull up the calculator, and we're going to put this in here. So we're going to go to y equals, and we're going to type in -x plus 4, and then we'll slide down here. We'll do 2x minus 5. We should get a picture that looks a lot like that. I'm going to go ahead and graph this in the standard window. That looks good right there. And let's just have this calculator find this for us. So we hit second and trace. That's the calculate menu right here. And then we end up hitting 5 for intersection. And then we just hit enter to say, yes, that's the first curve, enter for the second curve. You can guess if you want to, but you don't have to. And it crosses right there at 3, 1. So we did get that one right. Let's double check this one over here. So we're going to go back to y equals. We'll clear both of those off. And we're going to put in, let's see what we've got here. So this is going to be y equals 3x. And that's going to be on the top. And then we're going to divide by 2 minus 1. And then the other one's going to be negative x. And then minus 6. We'll go ahead and hit graph. That looks pretty good. And again, we can do this really quickly because when we're doing lines and we've only got 2 of them, it's just second and trace, number 5, and then enter, enter, enter. And it tells us -2, -4. So we're all set to go there. All right. If we need to come back and check those on a calculator, we will, but let's see how these other two turn out. See if it would be worth using a calculator on this. So I'm going to go to right there, and let's take a look here. That one's in slope-intercept form, so we're set to go with that one. I'm going to do this one in blue, so we're going to move this to the other side. This is going to be -2y. It's going to stay there. That's going to be -2x. And then we've got a -2 here. We're going to divide everything by -2. And we get y equals. Now you'll notice on this one and the one I did up above, I just divided both sides by -2. And then I kind of break this up into this term over the denominator and that term over the denominator. Totally okay to do that. If you did want to go through and just divide every term on both sides by that coefficient there, that would be fine. We end up with an x here, and we end up with a +1 right there. So I'm going to go ahead and put a dotted circle around that one. We'll graph that in just a second, and then here's the other one. And I'm hoping that you notice something about the two that we're going to graph. If I graph the first one, it crosses at 1. The slope is 1. Coefficient there's 1. So rise 1, run 1, rise 1, run 1. So we're going to go up 1 and right 1, down 1 and back 1, down 1 and back 1. So we get the line that looks like this. And then if we were to graph that blue one, the exact same thing would happen. So these would be right on top of each other. Okay, we'd follow that same stair-step pattern. We get something like this. So they are right on top of each other. They have a ton of points in common. In fact, they've got an infinite number of points that are in common. So we're going to write infinitely many solutions. But remember, we need to have the vocabulary that we mentioned in this unit. So we're going to call this, well, it's got an answer. So we're going to call this consistent. And we're going to call this, let's see, well, the answers for the blue one depend on the red one and vice versa. So this is consistent and dependent. Consistent and dependent. So we're going to go ahead and circle that right there. Now, we can't really, well, I guess we could list these if we put these in set builder notation or something like that. But we're going to suffice it to say that these lines are exactly the same. It's consistent and dependent. We have infinitely many solutions. Looks like that. And then we'll take a look at this other one here. So we're going to move the 4x to the other side. This is going to be -3y equals -4x. And then we've got this +6 here. So we're going to divide each term by -3. So you'll notice I'm doing that slightly differently, kind of like the way I did over here. So this is going to be, let's see, we've got 4/3 x, and then we've got -2. And we're going to go ahead and graph that one. And we need to graph this one right here. Now this is not one, whoops, let me change colors here. This is not one that we can type, ooh, still didn't change. There we go. Okay, this is not one that we can type into the calculator. So let's just go ahead and graph this. Remember, if you've got x equals a number, that's a particular type of line. It's either horizontal or vertical, and hopefully you can remember which it is. X equals a number, when you only have one variable, it tells you which axis you cross. So we're going to cross the x-axis right here, and that's the only axis that it crosses. So it's got to be a vertical line. X equals a number is a vertical line. Remember, it's straight up and down. There is no slope, or we say the slope is undefined for that. And then this one crosses at -2 and has a slope of 4/3. So we rise 4 and run 3, rise 4 and run, whoops, got to go a little further over. Run 3. So the opposite would be down 4 and then back 3, down 4. So that's off the charts right there. So let's just go ahead and connect those. And they cross right there. So that point is, let's see, back 3 and down 6. So this would be -3, -6. So there's the intersection point. They do have a point in common. There is a solution. So this is going to be consistent and independent. All right. And we've got to label a couple of points. So I'm going to label this one right here. That point right there would be, let's see, would be over 3 and up 2. And this intersection point, of course, is right there. And we'll just label this other one. I'll do that in blue. Okay, so that's going to be, let's see, -3 for the x-coordinate, 0 for the y-coordinate. So we've labeled a point on each one of the lines, and we are all set to go. All right, I've flipped the page. Let's go ahead and take a look at these. So this one says solve each system using substitution. So it's specifying the method that we need to use. We need to be good at substitution and elimination, as well as understanding how we graph them to solve. So let's go ahead and use substitution. This one's set up for substitution. Wherever there's a y, we're going to put a 2x plus 3. So we're going to put that, right in here. So this is going to be 3x minus, and then wherever there's a y, it's always a good idea to plug in parentheses. We're going to put this stuff right here. So this is a 2x plus 3, and then that equals -1. So we're rewriting the second equation. There's the 3x, there's the minus, there's the equal, there's the -1. The only thing that we're changing is instead of putting y right there, we're going to put what y equals. And then we'll just distribute through. So this is 3x minus 2x minus 3 equals -1. These two are going to be put together. We're going to end up with an x minus a 3 equals -1. So we're going to add 3. So we get x equals 2. So I'm going to keep track of that. But I'm going to take this, I'm going to go back here, and we're going to plug it in right there. So that means that y is equal to, let's see, we've got a 2 times a 2. Wherever there's an x, we're going to put a 2 plus 3. So this is 4 plus 3, so we get y equals 7. So we've got both of those. Now we want to make sure that we write the answer down in the correct form, remember. So we're going to write it down as an ordered pair. So this is going to be the point 2, 7. We're going to circle that, and we're finished with that one. We've shown enough work for everybody there. Now this one right here, we're going to solve this one by substitution as well. So wherever there's an x, we're going to put a -3y plus 6. So wherever there's an x, we put this in there. So there's an x right here. So I'm going to draw this line around here, and that's what we're going to plug in for. So this is -2, and then again, put it in parentheses. Where there used to be an x, we're going to put -3y plus 6. And then don't forget, we're back up here. We're not on the lower one, so then it's minus y, and then equals 3. Now I want to take just a second to make sure that we did this right. We've got the -2. We've got the -y, we've got the equals, and we've got the 3. And then wherever there used to be an x, we put a -3y plus 6. So now we'll go ahead and distribute. That's going to be 6y minus 12 minus y equals 3. At the same time, I'm going to put the two of these together. So this is going to be 5y, and I'm going to move that 12 over. I'm going to do that by adding 12. So we get a 15 on this side, and then of course we're going to divide by 5, so we get y equals 3. So I'm going to go ahead and put a dotted circle around that one right there. And now what we're going to do is we're going to take this y, and wherever there's a y in the problem, we're going to plug in a 3, and the best place to plug that in would be right here, because that will allow us to figure out what x is. It's kind of already solved for x. So this is going to be x equals -3. Y is 3, and then we're going to add 6. Again, all we're doing here is we've got the x, we've got the equals, we've got the -3, and the plus 6. The only thing that's changed is instead of putting a y right there, we put a 3. So this is a -9 plus 6, so we get x equals -3, and we're going to put a dotted circle around that. Now, I do want to make sure you're aware of something. If we find the y first, we're kind of in a habit of saying, oh, whatever we find first, that's going to go in the first place. That's going to be where the x is. But you've got to be careful here. This is the x value right here. So the answer on this one is -3, 3. If you put that backwards, you're going to get the answer wrong. So please be careful with that. Not only that, if we plugged this in for the x and the y, it would work. If we had those reversed, it would not make those true. So you've got to be careful with that. So let's take a look at a couple more substitution problems. We'll take a look at this one right here. This one is not solved for any one of the variables, so we get to choose. It's normally easiest to pick the one with a positive coefficient and the one with a small coefficient. So we'd probably be okay picking either one of these. If I move that 2x to the other side, though, it's going to be positive. So I'm going to go ahead and do that. I'm going to change this one. This is going to be 2y on this side. This is going to be a 2x when I add that to the other side, minus 6. So then we're going to go through and we're going to divide everything by 2. So we get this. We get y equals, this would be an x minus a 3. So we've got that part taken care of. Now we're going to go ahead and plug that in. So we're going to take this and put it wherever there's a y in the other one. So since I was using the first equation, I have to plug it into that second one. So here's what we're going to do. We're going to take this and we're going to put it right there. So we get 4x plus 2 times whatever y was. That's an x minus a 3. Okay, equals 18. So 4x plus 2x when I distribute through minus 6 equals 18. 6x, putting those two variables together. And then I'm going to move this to the other side by adding 6. So that's going to be a 24 there. Again, just saving myself a little bit of work and a little bit of time here. We're going to divide by 6. So we get x equals 4. Again, we're going to keep track of that. And the best place to plug this in would be right here. So we get y equals, this is going to be 4 minus 3. So that's going to equal 1. So y is equal to 1. So again, ordered pair, always x then y. So we put 4 here. We put the 1 where the y goes. And we're all set there. Okay, let's take a look at the next one. The next one's kind of interesting. It is solved for one of the variables. We've got y equals this stuff right here, but this has a fraction in it. That could be a little bit challenging. Let's see how this goes. So wherever there's a y, we're going to put this stuff. So we're going to put that stuff right in there where the y was. So this is going to be 2x and then plus 3, and then again in parentheses, negative 4/3 x plus 5, close the set of parentheses, and then we set that equal to 1. Again, there's the 2x, there's the 3, there's what y is equal to now, and then the equals 1. Now, we do have a little bit of an advantage here. Take a look at what happens. We've got the 2x, and when we multiply by 3, those 3's cancel. So we cross-cancel those 3's when we multiply through, so we end up with a negative 4x. Distribute through here. Again, when we say cancel off the 3, it's just canceled when we multiply by this term. That 3 is still in effect for the 5, so this is plus 15 equals 1. So we get negative 2x between the two of these. We're going to subtract 15. And let's see, this is a negative 14. We're going to divide by negative 2. So x equals 7. So we've got that part right there. And now we're going to take this and we're going to plug it in right there. So take a look at what happens on this one. We've got negative 4/3, and we're going to multiply that by 7, and then we're going to add 5. Now, if you want to have your calculator help you out with this, that would be totally okay. We've already got one of the answers, so at worst, we're going to have one part of this that turns out to be a fraction. So let's take a look at this. Again, I went ahead and made that a fraction by putting it over 1. So this is going to be y equals negative 28 over 3, and then plus 5. But I want to go ahead and make that into thirds so we have a common denominator. So this is 5 over 1. If I times that by 3 to make the denominator 3, I need to multiply the top by 3. So this is going to end up being, let's see, negative 28 plus 15. This ends up being negative 13/3. So that's what y is equal to. So we've got our x. It's a 7, so we'll go ahead and write that down. And then our y turns out to be this ugly fraction right here. But at least we didn't get that fraction until the very end. So we're all set with that one. And we're going to go ahead and slide down and take a look at this next part. So as we slide down here, we take a look at the instructions. This says solve this using elimination. So we'll go ahead and solve this using elimination. These two are already set up because they're opposite signs. So let's go ahead and take advantage of that. We're going to multiply these two so they're the same number, same coefficient, but different signs. We've already got the different sign taken care of. We need to turn both of those into 6's. So I'm going to multiply that one by 3. And this one by 2. So let's go ahead and distribute through here. This one's going to turn into 6x plus 6y equals negative 24. And this one's going to turn into 6x minus 6y. And then let's see if we multiply that. That's going to be 36. Yep. Then we can combine these together and notice what happens. We've eliminated the y's, which is what we're after. We get 12x equals negative 24 plus 36 is 12. And we're going to divide by 12, so we get x equals 1. Again, we're going to hang on to that. Remember, elimination is nice, but you can't solve problems using elimination unless you know how to do substitution, because we've still got to figure out what y is. We've got 4 true equations here. We want to plug into the one with the smallest numbers and probably the fewest number of negatives. So I'm going to take this and I'm going to plug it in right here. Plug it in for that x right there, because this one has the smallest numbers and the fewest negatives. So we're going to do 2 times 1, because that's what x is, and then 2y equals negative 8. So we'll subtract 2 here. Okay, so this is going to be 2y equals, this would be negative 10, and we're going to divide by 2, so we get y equals negative 5. So there's the other one. So we're going to write 1 comma negative 5, circle that, and we are all set to go. Now remember, all it said we had to do was just solve them. It didn't say we had to write down consistent, inconsistent, that sort of thing. So we're all set here. Let's go ahead and take a look at this. We could turn those into 12s, or we could turn these into 6s. Again, it's generally better to keep these smaller. So I'm going to go ahead and multiply this one by 3. And this one by 2. Just happens to work out the same as that one right there. So let's see what we get here. This is going to be 6x. This is going to be 9y. That looks like a G, but that's okay. And then on the other one, let's see, we end up with a negative 6x and then negative 8y. That's kind of interesting. And then 0 over here. So let's see. We get no x's, and we get 1y, and we get a 3. So that quickly we know that y is equal to 3. And again, we can plug this anywhere we want. Equation 1, 2, 3, or 4. Any one of those is fine, but we're going to plug it into the one with the smallest number and the fewest number of negatives, so we're going to plug it in right there. So this is going to be 2x, 3 times what y is 3, equals 1. So this is going to be 2x plus 9 equals 1. We're going to subtract the 9. 2x equals, let my computer catch up here, negative 8. And we're going to divide by 2, so we end up with x equals negative 4. So we got both those taken care of. All we need to do is make sure that we just write these in the correct order. So this is going to be a negative 4 for x, and we're going to put a 3 for the y. Circle that, and we're all done there. Slide down and take a look at these last couple right here. Okay, now we do need to be a little bit careful with this one. This one says solve this using elimination. You might be tempted to just go for it and just add these, but notice where the equal sign is on this one. We need to get these in what we call standard form, so we're going to move that 4y to the other side. So here's what I'm going to do. I'm going to leave the x right here. If I move that over there, I'm going to be adding 4y, and then I can leave the 11 on this side right here. So take a look at that. There's the x. We moved the 4y to the other side by adding 4y, and then the 11 would still be over there. It's all set up for elimination, so here's 10y. 19 plus 11 would be 30. We'll divide by 10, so we get y equals 3. Again, that quickly we've got one of the answers. And the cool thing about this is we've got 3 different equations that we could plug in, but one of them is all set up. If we just put that right there, this is going to say x is equal to negative 4 times 3 plus 11. This would be negative 12 plus 11. And let's see, so that's x equals negative 1. So we've got those two. Again, we just need to make sure we put them in the correct order. So we're going to put negative 1 for the x, and we're going to put 3 for the y. We're going to circle that. All done with that one. And the last one on this page, let's take a look. So this is kind of interesting. These have the same number but the same sign, and these have different coefficients and the same sign. So here's the cool thing about this one. All we need to do is just change that to a negative. So I'm going to multiply that, and we're going to get a negative 3x. We're going to get a plus y, and we're going to get a negative 13. Let's see, I think I did that right, yeah. Then we're going to combine these two right here. So let me just highlight that. The ones we're combining are these last two in this stack right here. So we're going to combine the two of those. So when we do that, here's what we end up with. No x's, which is what we wanted, and then we have a negative y equals 7 minus 13 is negative 6. So that means y is equal to 6. So I'm going to go ahead and put a dotted circle around that. So that one wasn't too bad. So which one should we plug into here? Well, it really doesn't matter, but if you take a look at this one here that we had multiplied by a negative actually is kind of nice because it's got that positive y. So I'm going to plug this in right there. So this is going to be negative 3x, and then this is going to be a plus 6, and then equals negative 13. And we're going to subtract 6, and we're going to get a negative 3x over on this side, and then we get a negative 19 there. Now, we might be tempted to look at this and go, oh, crap. If I divide by negative 3, well, that's weird. This doesn't go in evenly, but that's okay. We think of that as a fraction. We see if we can reduce it. We can't reduce it, but we can simplify it by doing a negative divided by a negative. So this is 19 thirds here. So we've got the x value and we've got the y value. So this is 19 thirds, comma 6. Circle those, and there we go. Now, can you imagine trying to find that with a calculator, or sorry, just by graphing? That would be kind of a pain in the butt. And if we did find it with a calculator, it'd be kind of an ugly decimal, but we could probably convert that into a fraction or something. So let's take a look at this last page. On this last page, the instructions are slightly different. It says solve each system using any method we've learned. So you get to choose whichever one you like the best or whichever one's appropriate. And then we also want to make sure we use the appropriate vocabulary to describe the system. So that's going to be that whole consistent and dependent, consistent and independent, inconsistent, that sort of thing. So let's take a look at number 13 and let's go for this one. This one's a tough choice. We could turn both of these into 12s or we could turn both of these into 14s. We just need to make sure they have the opposite sign. Really doesn't make any difference. I'm actually going to do this one. I'm going to turn this one into a 14 because what I need to do here is I just need to multiply by 2, and multiplying 33 by 2, that's a big enough number. I don't want to multiply by anything bigger than that. So we're going to go ahead and multiply by 2. That's going to turn this into a negative 14, so we need to turn this into a positive 14. So we're going to multiply this by, let's see, we'd have to multiply by negative 7. So let's see what we get here. So this is going to be negative 21x. This is going to be plus 14y, and this is going to be negative 14 over here. And then right here we've got a 8x, a negative 14y, which is what we want, so that's going to cancel that off. And then we've got a 2 times 33, so that's going to be a 66. So then we'll just go ahead and combine these and see what we get here. We get a negative 13x over here. Again, those cancel each other out. We've eliminated the y's. And then we've got 66 minus 14, that's going to be 52. And if we need a calculator to help us out with that, we could totally do that. This is going to be negative, and 13 goes into 52. If you double check me on that, I believe it's 4 times. So we're going to go ahead and circle that one. We've got our x value. And then I probably want to plug this one into, I would say, that very first one. Again, the smallest numbers, fewest number of negatives. So we've got an x value. We're going to plug it in right there. So this is 3 times negative 4, and then minus 2y equals 2. So this is negative 12 minus 2y equals 2. Move this over, so we're going to add 12. So negative 2y equals 14. Divide by negative 2, and we get y equals negative 7. Okay, so we've got both values there, so we do negative 4 comma negative 7. Circle that and we're all set. Remember, don't forget this other part where we have to describe the system. We haven't looked at this, we haven't graphed this, but we know that it crosses in one point. So this is going to be consistent and independent. All right, so we've kind of got 2 parts to the answer there. So the point and the description. So we'll take a look at this next one. Now, again, we could use any method we want. I'm going to solve this one by substitution because it's really set up for this. Wherever there's a y, we can put this stuff in its place. So let's just be careful with this. This is 4x equals, and then we have 3, and then let's put this in parentheses. So negative x minus 3, and then plus 44. So we'll distribute through. 4x equals, this is negative 3x, this is negative 9 plus 44. I'm going to move this to the other side, so we're going to add 3x. So this is 7x over here, and we'll go ahead and simplify this. Negative 9 plus 44 would be positive 35, which makes us feel good because we know that 7 goes into 35, so we're going to get x equals 5 on this one right here. Okay, so we're good with that one. And because we solved this using substitution, and we already know what x is, we can just put that right there. So we get y equals negative. Now I'm going to do this. I'm going to put that in parentheses. So this is a 5 minus a 3. So we've got a negative in front of the 5. So of course that's negative 5 minus 3. So we get y equals negative 8. So we've got those 2 pieces right there. 5 comma negative 8. Don't forget, we need to describe what this is, use the appropriate vocabulary. So this is going to be consistent and independent. I'll just go ahead and write out all the words right here. Okay, so consistent and independent means it has an answer, and because it's independent, the 2 lines would not look like each other. They just cross in one particular point. Okay, let's take a look at number 15. Let's see, I'm thinking this one's going to look good for elimination. So here's what I'm going to do. I'm going to multiply this one by 2 because that's going to turn that into a 6. And I'm going to stack it right up here. So this is going to be a 6x. This is going to be a negative 4y. And this is going to be equals 6. And then take a look at what happens when we put these together. If I put those two together, I get no x's, I get no y's, and over here I get 6 minus 6 is 0. So what that means is 0 equals 0. So stop and think about that for just a second. This equation, the point of solving equations is to make sure they're true, or find a number that makes them true, or a point that makes them true. This is going to be true no matter what. So these two lines are copies of each other. We're going to have infinitely many solutions. We could put it that way. We could also put it another way because we've got some vocabulary for this. This is consistent. Whoops, consistent. Get rid of that. There we go. Consistent. And remember, the two lines are the same. That's why they're infinitely many. So the answers for one depend on the answers for the other. So this is consistent and dependent. I'll spell the whole thing there. Okay? All right, let's take a look at the next one, number 16. I think this one's set up for elimination also. I'm going to take this and I'm going to multiply it by -5. So let's see what we get here when we distribute this through there. So we're going to multiply both sides by -5, so that's going to be -5x. Take a look at what happens here, -5y, and this is going to be 25. We're going to add these last two together. Again, it's just these guys that we're combining right here. So when we put those together, let's see, we get no x's, so that's going to be 0. That's going to be 0. And then on this side, we end up with a 20. Well, this is a completely different story than what we had over here. Here we had 0 equals 0. That's going to be true no matter what. So anything that works in one is going to work in the other. But this one right here, we get 0 equals 20. So what that means is we don't have any answers. We have no solution. So we're going to write no solution. And we're also going to use the correct vocabulary for this one. So do you remember what that is? It is inconsistent. Inconsistent. Inconsistent means it doesn't they don't have any points in common. So stop and think about what that would mean for the lines. Those lines would have to be parallel. Okay? So just kind of keep that in mind. We've got the last two to take a look at, and then we are all done with this. You can do the self-assessment, and hopefully you're ready to go on the test. The mid-test, actually. So this one here is set up for elimination, clearly, so take a quick look at that. Didn't have to do any work. All we had to do is recognize those have the same coefficient but opposite signs, so let's just add them together. We get 2x over here, no y's, they're eliminated, and we get 18. Divide by 2, we get x is equal to 9. So we've got that one taken care of. Now let's plug that back in. I think I'm going to plug into that first one because it's positive, so we're going to put this right here. So we get 9 plus 7y equals 13. And we're going to subtract the 9. So we get 7y equals, let's see, 13 minus 9. That's going to be 4. And we don't panic here because we are totally okay with this. We know that this is just a fraction, so we're going to leave that 4/7. There are the two answers. And we just want to write it as an ordered pair. So if we were to graph the two of these cross at 9, 4/7. And if you wanted to double check that on your calculator, you certainly could. In fact, maybe we'll do that in just a second. If you've got time on a test, certainly wouldn't be a bad idea to grab that calculator and have it double check. This one right here, also set up for elimination. We've got a -x and a +x. Notice that the y's are on that side also, so we didn't have to do any rearranging like we did on that previous one. So we're going to end up with no x's. We're going to end up with 8y, and then on this side we get a 32. 12 plus 20 is 32. We're going to divide by 8, so we're going to get y equals 4. So we've got that one. And now we're going to take this and we're going to plug it in, probably right here. So this is going to be x plus 6 times y, and y is equal to 4. And then that's set equal to 20. So this is going to be, that's a 24. So I'm just going to subtract 24 there. So we get x equals -4. And then we've got the two answers. So we've got, let's see, -4, 4 for the y. We're going to go ahead and circle that. Now, a couple quick things. I kind of did this on purpose. You'll notice we got to the end of the page and we get carried away. We start solving everything, and we might forget part of the instructions. Remember, we've got to say what this means. This means this is consistent and independent. And if this has one answer, this is also consistent and independent. All right. Now, just for the heck of it, if you don't want to watch this, you don't have to. I'm going to grab a calculator, and we're actually going to throw this in there and see if we can get this to work out. So this one right here is going to be y equals, if you move this to the other side, it would be a -x. And then we would end up dividing by 7. So this is going to be negative x over 7, and then plus 13 over 7. Okay, because when we divide everything by 7, that's what we'd get there. And then the other one, I'll do this one in blue. This one's going to be y equals, now watch what happens here. I'll do the work over here. Negative 7y equals, this would be negative x, and then we have a plus 5. So we divide everything by negative 7, and watch what happens here when we divide by negative 7. This is going to be a y equals, this is going to be positive 1/7, okay, and then this is going to be negative 5/7. So we've got, I'm just going to do this as x over 7 minus 5/7. So we're going to go ahead and graph the two of those. So I'm going to shrink this down so we can see the calculator. I'm going to go to y equals. We're going to clear this off. And again, you don't have to do this, but if you've got time, it certainly wouldn't hurt. We're going to type in negative x divided by 7. And then we're going to add 13/7. Just a nasty, nasty mess here. Imagine doing this by hand. And then the other one is I'm going to do an x divided by 7. And then we're going to subtract 5/7. 5 divided by 7. Okay. We'll double check and make sure that we've got this in the right way. Okay. I think everything looks good there. So we're going to go ahead and hit graph. Okay, and we're looking for something that crosses at 9 4/7. So gosh, that looks pretty good right there. Now, even though the window doesn't look good, I think it still crosses within the window from negative 10 to 10, that standard window. So I'm going to hit second calculate. 5 is the intersection. We hit enter, 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 and we get this right here. So it's 9, and so we've got that part right, and then we've got 0.571. Okay, so let's do a couple of things. 4/7, 0.5714. So I'm going to hit second quit. 4 divided by 7. 4 divided by 7. Oh, there's that 0.5714. And then also, this is actually kind of cool. Let me see if I can find this. Let's grab y. So I'm going to hit alpha y. And then I'm going to see if we can pull up that number. And there it is right there. Okay, so that's the y that was previously stored in the trace menu. So that you can see that they're exactly the same. So I think we're in good shape there. Good luck on the mid-test. Make sure you get all the help you need.